In the session, we shall try to discuss about a use case where we are going to have a Spark application, uh, you know, uh, designed in this way. That is, there's already data in some in HDFS. There is some data in HDFS, and this HDFS has a directory. The data is in a directory, and in this directory there are some files. So these files are sequence files. These files are sequence files. I think already those who are familiar with sequence file, they might have known what is a sequence. They should know what a sequence file is. Otherwise, I will give a little introduction, idea of what is the sequence file is. That's fine. So a directory is there. In that, it has certain files which are sequence files. Now we need to develop a Spark application, design a Spark application to read the data from the sequence files. They are not text files. I'm telling you, they are not text files, they are sequence files. So it has to read the data from the sequence files. Actually, it is some data, weblog data, log data. There is a weblog data actually. So the data must be read by the Spark application from HDFS, and it has to get the required information from it. That is, actually some fields are required in it. I will let you show the data now. So some data we have in that, we have to get the required information from those file from those records of the files, and finally we have to load them to Hive. We have to load the results to Hive. So even the people who are already who have the idea of this HDFS or Hadoop, they should know what the Hive is. So Hive is a data warehouse. HDFS is a storage system, log data. So this we are going to everything internally, in between we are going to implement everything by using Spark, the implementation, and this Spark application has to read from it, process it, and finally load the result into Hive warehouse. So in Hive, the data is stored in the form of what? Tables. And in HDFS, the data is stored in the form of files. As it is a file system, it is a warehouse. Files, tables. So now the Spark application has to read the data from directory, that is from the files, and it has to write the data into Hive as a table. It has to write as a table. We have no voice. 1 second, please. Right? Is it fine now? Are you able to hear me? Hina, is it okay now? Okay, right. Now, I will show the file. Just I will try to show the data. Just observe it. Mm, sorry, this is. Let me go to HDFS, and in HDFS, just let me stop this one application. No. So in HDFS, you will get this. In the when you go to browser, you will get all these options. So go to Hadoop, name node. Fine. Okay. Just to scroll down. If you want to get into this HDFS file system, just to scroll down. In the bottom, we'll have something called legacy UI. We'll find it that will be watermarked actually. But if you place the cursor, it will be it will show this symbol, pointing symbol, referring symbol. Just click on it. We'll go to the legacy UI. That is this is the UI of Hadoop in one version, that is 1.x versions. This is the UIF of Hadoop, that is the HDFS name node in Hadoop 2 versions. But we can't see the data directly in Hadoop 2 UI. We can see the data directly in Hadoop 1 UI. That is what we are going with legacy UI, and browse the file system here. This is called as a file system. We get into here, and under user and under Cloudera. This is a weblog data. We have a folder called as weblog data here directory. Just open this. These are different files. these are all the files. Okay, the many files are there, small size files are there. Just let me open one file. Can you see this data here? What is this type of data? This is called as sequence file. This data is stored in the form of sequence file. Okay, sequence format. Format. This is a sequence format in which the data is stored. You can see here something in the beginning is here Q. Okay, thus it states that it is the sequence file format. Okay, and I will let you know what the sequence file format is now. Okay, fine. So the data is not exactly text file. It is not stored as it is. It is stored in another form that is called as sequence file format. Okay, so now let me just explain, give a little introduction to this sequence file. So when we talk about a sequence file, in this the data is stored in the form of key and value. Remember, in the sequence file the data is stored in the form of key and value. Key will be long. There is nothing but a number. Key will be a number, that is offset. Already we have known Hadoop, they might have known what is that offset is. Okay, it will be, just remember here that the key will be long and the value will be bytes writable, bytes in the form of bytes, long and bytes. Okay, so it will be an numerical and it will be in the form of bytes. So sequence file generates the output or writes the data in this form, key and value. So every record will be of the form key and value. Remember this point. So key data type will be long and value data type will be bytes. It is not string, it is not integer, nothing. It is simply bytes. Remember that point. Okay, we can observe here. Here we can observe the data type sheet. This one, just observe here. Long sequence of long writable. You can observe this long writable and org.hadoop.bytes writable. So this long writable and bytes writable, these define the types of key and value. This define the type of the key and this is the type of the value in every pair of sequence file. That is in every pair of sequence file records. Okay, long writable and bytes writable. Long writable and bytes writable. Okay, these are the data. Generally, if you take any programming language, okay, generally if you take any programming language, what would be the data types? We'll have integer, we'll have long, we'll have float, short. But what is this long writable and this bytes writable? These are the you know long writable, float writable, and this bytes writable. So what are all these? These are the you know data types of HDFS, Hadoop storage system, or Hadoop file system. Hadoop file system, we can say that Hadoop file system. These are the data types, or the type of data, how the data is stored in HDFS, that is called as the types of the Hadoop file system. Remember that point. This is not the type of any programming language. This is the type of Hadoop file system. Remember that point. Okay, long writable, bytes writable, we have int writable, okay, and we have text. All these are the formats, data storage formats of Hadoop file system. Remember this point, Hadoop file system. Or data type, we can say the data types of the Hadoop file system. Now, so I will show you that in Hadoop. Just let me give a brief introduction of this one. In Hadoop, there are different data storage formats. Okay, in Hadoop, the data is stored in the form of files only. But the first, type of data storage is text storage, text to file format. Okay, second is sequence file format. So these are the various file storage formats. And third is DB input format, DB file format. There are different types of formats are there. And key value input format, key value format, file format, different file formats. And we have Avro format, and we have Parquet format, ORC format, Parquet. All these are the different file storage formats in Hadoop or HDFS. I can say, sorry, HDFS. HDFS is a file storage file system, right? Okay, these are the various available files and data storage formats in HDFS. These are the various data storage formats in HDFS. Okay, if we are loading the data as simply as a text, that is called as text file format, sequence file format, DB file format, key value, Avro, ORC, Parquet. We'll come to note one by one. One of the in every use case we'll learn about one of these file systems or file type of files. Okay, so all these are the different data storage formats. I'm telling you, data storage formats in the form of files. Everything is stored in the form of files in HDFS, but there are different data storage formats in HDFS. Remember this. Now we are going to discuss about this. We are discussing about the sequence file format. In sequence file format, the data, every record in the file is stored in the form of key and value. Every record is stored in the form of key and value. And what is the data type of key? Data type of key will be always long, and the data type of value will be always bytes. Always bytes, long and bytes. So sequence file format is one of the data storage formats in HDFS. And in sequence file format, how the data will be stored? Okay? The data is stored in the form of a pair. Actually, every record is a pair. So what is the pair? Is key and value. Okay, so and in HDFS, this long value is the data type of long is mentioned as long is specified as long writable, and value is specified as bytes writable. Long writable and bytes writable. These are the data types. These are the data storage formats. These are the data types. Remember that. So what are different data types available? Or into writable is one data type. There are many data types are available. Let me show you all the data types now. Byte writable, long writable, float writable. These are all the data types of files that are stored in HDFS. So the data stored in HDFS, and we have some float writable. All these are the data storage for data types of data that are stored in HDFS. Okay, now we shall discuss about this. We are going to read the data of sequence files. So let us try to see. So in order to read the data from sequence file, whether we have to read that for data as a RDD or a data frame or data set. Now how shall we read that file? Okay, so this here we have in HDFS we have sequence file. This is fine. Now we have to read this file into Spark environment. We have to read this file into Spark environment here. Okay, so in Spark environment we can have the data as either RDD or data frame or data set. That we have discussed. We did not discuss about data set, but we have discussed about RDD and data set. So when we go with RDD, creation of RDD, when we go with creation of data frame is, remember, for structured and semi-structured. For structured and semi-structured, general we go with data frame, and if it's unstructured, general we go with what? RDD. So here the sequence file does not have any schema. Remember that it does not have any structuredness for it. So directly we go with reading of this sequence file as RDD. Okay, remember this point. So we have decided based on the data that is that we're trying to read. So we have to decide whether to read it as RDD or data frame. So here if you try to read the data as a data frame, compulsory the data should contain some schema, at least partial schema, that is unstructured, semi-structured. Without schema, it is not recommended to go with creation of data frames. So this sequence file does not have schema. That is the reason we go with creation of what? RDD out of this file. Got it now? Any questions in this, please? Yeah, Hima, any questions? And Venkatesh, so please anyone, if any questions, please let me know, otherwise I will continue.
So is it like all the sequence files will always be read as RDD?
Yes, we do not have the API to read sequence file as data frame in Spark. Actually, we do not have the any functionality or any API to read the data of a sequence file as data frame. We can read it as RDD only.
Yeah, Karnataka, one more.
Yeah.
So this sequential file would be a kind of semi-structured file, right?
Semi-structured. How do we call it as semi-structured? Why? No wonder why now. Sometimes you're saying sometimes, right? What would be? Can you tell me some one case where it can have sequence, some style, what you call a schema?
No, it's a key value pair format, right? Just like JSON. So we consider it as a semi-structure, or it is a kind
No,
of
no, 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 no.
uh,
That is not
unstructured.
no, no, no. It will be still semi-structured one. There is not simply plain for semi-structured one. No, sorry, unstructured only. We can't call it as
Mm.
it is having schema. No, it doesn't have schema.
So it should be semi-structured or like unstructured, right?
Unstructured, unstructured.
Okay.
Hima, any questions from your side? Hina, it's fine. So let us open the putty. Cloudera. So and the password is also Cloudera to connect to it. So just me let's increase the font size. Okay. So to launch this Spark application, Spark-shell. So first we try to understand, with interactive mode. We shall try to understand with interactive mode, interactive application. Later we shall develop the batch application in IntelliJ. Okay. First we shall try to go with Spark interactive application just by hitting Spark-shell. Let me open one more putty here, one more connection. Okay, that's fine. So I will use this window for seeing the data of HDFS. So now here HDFS DFS hyphen ls user cloudera slash weblog data. The directory name is weblog data. Okay, there are many files are there. Let us just try to. So this is the location actually where we have the data in HDFS user cloudera and weblog data. There are many files are there. So many files are there in that. There are many files. Okay, just you can see the different files are there. That's fine. Now let us try to read the data from here. So to create RDD, what we use here, we use Spark context, and to create data frames or data sets, we go with SQL context. So now we have to go with SC here. So val control L val RDD1 equal to SC dot. So this is not a text file; it is a sequence file, isn't it? So we don't use text file here. Here we use sequence file. We use sequence file. Sorry, I think the spelling is wrong. sc.sequence file of, give the path of that file, that is in hdfs colon double slash localhost, or you can give the name of it 172.16.38.116 colon 8020 slash user slash cloudera slash what is the file directory name, weblog data. This is the file path. That is the data path actually, where do we have the data in HDFS. After this, we need to provide, the type of the key and the type of the value. The type of key and type of value. How do we provide the type of key and type of value? Is those type and those types, the type of key and type of value are available in Hadoop library, not in Spark library. They're Hadoop in Hadoop library. So we use like this org dot Apache dot Hadoop dot io dot the first type is key type is long writable comma okay org.apache.hadoop.io dot long writable followed by org.apache.hadoop.io dot bytes writable. Close this. Okay, sequence file of file path, the path of the file, the path of the data, and what do you call as Hadoop, the key type and value type. Let's just hit enter.
So those are the data types, right, Karnak?
Yes, data types.
Long
Data types.
writable and byte writable are data types. So we have to give the data types of the. So if we don't know the data types, then how would we approach the data?
Yes. How to know the data types? You are asking about that.
Yeah.
Yeah.
I mean, if we have to give like this, right, we have to know the data type, right, of the data.
Yes. When we see it in
So how do we know?
that's what I showed right here. That's what I have shown here in this. That's what I have been trying to show here. Sequence file,
Okay.
long writable and bytes writable. Here I have this. Okay.
Okay. Okay. Okay.
Right. Actually, sorry, I have missed some point here. It must be class of long writable, and it must be class of okay. This is how we specify reading of data from a sequence file. Remember that. So whenever you have sequence file data, first provide a c.sequence file, the path of the string, but the path of the data, and the class that is there's nothing but specifying the type of the key and specifying the type of the value. That's fine, right? Right. Now after this, this is not going to directly read the data here. We need to convert it into Spark understandable format. That is, we do rdd2 equal to, now here each record is made up of how many fields? Two fields, right? Key and value. Each record is made up of two fields, that is key and value. Okay, so how it is, let me show you that. rdd1 dot map of x implies x dot underscore 1 dot to string comma x dot underscore 2, sorry, new string of x dot underscore 2. Let me use like this, dot get bytes. That's fine. I think one more is required here. One more. Okay, this statement is going to actually convert the data of Hadoop data into Spark understandable format. Remember that. Okay, this statement is going to, what is the, when do we use map method, map function here? When do we use map function? Already we have discussed in the previous sessions. When do we use map function? If you want to apply some logic, this is the logic I'm trying to apply here. I'll come to it. What is that logic is? That is, if you want to apply some logic or some functionality on every record, on every data element, then use map function. Okay, so x here, x is nothing but every record. If x is the record, so the first record, that is a key, I'm trying to convert into a string, and the second one that I'm trying to convert into a string. Okay, string and string. Why do we need to convert into string is, even though it is long writable, it is bytes writable, we cannot directly read them in Spark. So that is the reason we need to convert into first the understandable form, that is called a string. Later we can convert the data types of whatever we can do, but initially, even though it is long, do not use long, what you call as too long here. Use two string only. Why? Because this is a basic conversion from Hadoop data to, that is Hadoop format data to Spark understandable format of data. Okay, so we are converting, we are reading that key as string, and even what you call as that value also string. Value as also string only, but value is bytes. It actually is in the form of bytes. We need to get the data from the byte. That is why we use this function. Remember this. So this is about, can you tell me what is the x dot underscore 1? What is x dot underscore 1? What is x dot underscore 2? What is x dot underscore 2?
Is it
Field one and
adding the
field
first
two.
Yes,
element?
yes. For this is the first field. This is the second field. Just let me give a brief idea about that. See here now. So every element is made up of k and value. Okay. So this is nothing but x we are assuming. So x dot underscore 1 represents k. X dot underscore 2 represents v. That is value. This represented as key. This represented as value. We can access it by using dot underscore 2 dot underscore 1. This we are converting into string. Why? Because it cannot be converted directly into Spark understandable format. So that is the reason we are converting into string. Okay, both we are converting into string. That's what we are doing in the second step. Okay, now let us try to print two records, not all the records. Let us see how many records are there in this. Totally, how many records are there in all the files. So for that, what is the function we use? Count. Just hit count. What is that error? Input path does not exist. Cloud era weblog data. Don't we have this path? I think this path is there, right? Does not Hadoop HDFS 60. So otherwise, let us go with the local host here. Maybe that is the problem. Local host. RD2 more brace and RDD2 dot count. Still it is showing directory. So I think it must be a file. It must be a file. I think directory we cannot give the directory. May not be. So what we have to do is, let us take a file only. Just let us take a file. Instead of taking direct, let us take some file. So in this, there are many files are there in this. Just let us take one file. There are many files are there. Let me take any one file. Open one here. Here weblog data. Yes. Next rd2 equal to this and rd2 dot count. Still, what is the problem again? Second. Input path does not exist. User cloud error. Isn't it, or is any change? What is the command? Weblog data only, right? User cloud error only. What is the problem? Just a second. Mm. Input path does not exist. Cloud error weblog data. It is there, right? Already. It is not working. Let me count here itself. rdd1 dot count. Input path does not exist. Fix dot count is a user cloud error. Weblog data. Don't we have that files is there, right? Already. What is not giving? It is throwing error. Just one second. I will go to this and directly copy the file path here. User cloud area only web block data. This is the path, right? What is the problem? Let me copy this path. Otherwise, let me copy one file. 1 second. There's one file is there. Even in this, we have some sequence files. Only even these are sequence files. So let me take this file. There may be some problem with the data. Yes, let me take this path. Some flume data directory, flume data. Yes, it is working now. There is some problem with the data. Not probably. So there are totally 3,440 records are there in it. Now let us go with RD2. We have RD2 conversion. This is RD2, and if we do a count of RD2 also, the number of records must be same. Why? Because we are applying map logic on every record. So correspondingly, the logic has to apply to all the records. We have to get same number of records. Okay. Now I will try to print some sample records, some 5 records like that. Okay. RD2 dot take of some 5 dot for each of println. Can you see this now? Data here. This is the data. The first field. This is the key, and this is the value up to here. Got it? Key
So,
and value. Yes.
Karnakar, I
Yeah.
have one question.
Yeah.
Take
Please.
of 5 is like we are taking 5 records from 3,440 records, right? Does
Yes.
it pick it randomly or the first 5 records?
No. In the sequence, in the order, starting from first
In
file to
order the
last file, all the files. This Flume data is a directory. It is not a file. It is a directory.
yeah.
Okay.
Okay.
So it will pick the data from all the files present in it. All the files, not just one
So
file.
it is picking each record from first 5 files. Five
Yes, yes.
five
Here,
files, right?
this take this. What is the operation we have performed? Take operation. It will pull
Yeah.
the first top 5 records from the first file. Top five
First
records.
5 records.
Top
Okay.
five
Okay.
records. Top 5 records. Okay. Just to know whether the data is loaded successfully or not, we need not to print all the records. Just that's why I'm printing out just sample 5 records here. Okay. So this is what. So now we are not interested in this key value, but we are interested in the value here. Actually, we require the value prop from this. So how shall we select only value from this now? From this RDD2, RD is made up of 2 fields. If you print RDD simply RDD2, it shows. Okay, the first is the key and second is the value. Every record is a form of a pair, right? Key and value. But we are not interested in key, we are interested only in value. Then how do we extract only value from this RDD2?
By using map function with field 2,
Yes,
x implies
exactly.
2.
RDD3 equal to RDD2 dot map of x implies. So x is entire record. I need only the second field. This is how we can use. Okay. And if you print this RDD3 now, then we get only the values from it. That's it. Very simple. Fine. We got the data. Now this is the data. Finally, we could load successfully the sequence file into Spark RDD. This is what we have done till now, nothing else. So just me list once again write down all the steps. This is the first step. Okay, first read, trying to read the data from what you call a sequence file and RDD2. You do have it. This is RDD2, that is converting the data of Hadoop data format into Spark understandable format, and next extracting only the value from it. So these are the 3 steps just now we have performed. So finally in RDD3 we have all the records. Okay, now we need to extract our required data from this RDD3. That's what we have to do now. So what is that we are looking for is, this is what. Now I am going with only 3 fields from it every record. So I want to get this what you call as IP address, this IP address, right? IP address, port number, and this timestamp. I want these three fields. So how shall I extract? How shall I extract these three fields from every record? Every record. I don't want remaining stuff. I want only these three fields from every record. How shall we extract them? Any idea?
A kind of substring or slice.
So substring or slice. Actually we can use substring and slice, but here we have to make that functionality as generalized. Why? Because suppose here in this the first record or some of the records, let's assume the IP address is in the starting, in the in the very first field is IP address itself. Let's assume that if the IP address is somewhere in the string, somewhere in the different location, then how shall we use this slicing or substring? That can't be used directly. Why? Because for substring or slice we use index there. So if the index changes for the IP address in some other record, then that might not work there. So we have to generalize
Mm.
that location. So wherever maybe
So,
wherever maybe that particular field in the record, we have to get it. That should be our intention.
so that should be regular expressions,
Yes.
right?
So in that case, we take the help of regular expressions. Okay. So to get the data from it, first we need to define the pattern. That is regular expression for IP address, for what you call as port, as well as the what you call as this one. What is this? Timestamp. Okay. Now let us go with val IP underscore pattern or regular expression is equal to. It is made up of what? General IP address is made up of general. What is the format of IP address? It is 32-bit IP address. 32-bit IP address. So the range of the IP address will be 0 to 255 dot, and again 0 to 255 dot, 0 to 255 dot, 0 to 255. Maximum, minimum and maximum value. So the number of digits will be minimum 1. Number of digits I am telling you. Number of digits minimum will be 1 and maximum 3. Not more than 3. This 255 is maximum 3 digit. It is a 3 digit value. So how do we define a regular expression for obtaining this particular format is 0 to 9. So it can be a number, any number between 0 to 9, and the size, the number of digits must be at least minimum 1 and maximum 3. This is how we define a regular expression for, sorry, a pattern for each, each 8-bit address. This is 8-bit address. This is 32-bit address. It is 8-bit address. So similarly we specify 0 to 9 for again 1 2 3 dot, using dot as a separator here. This is how we specify the what you call as regular expression. Already we have seen this how to form a regular expression in Scala programming sessions. So I need not to discuss about it again. So 0 to 9, minimum number of digits are 1 and maximum number of digits are 3, and followed by a dot. Dot is there. Okay, and again 0 to 9, 1 2 3, and again one more dot, and 0 to 9, 1 2 3, and finally 0 to 9, 1 2 3. That's it. It's over. Close it. Dot or. Is everything fine, or did we any uh, type all the brackets and straight curly braces and the straight braces correctly, or did we do any mistake? I think it is fine. Okay, this is for getting the first field, first digit, sorry, first number, second number, third number, and for totally 4 numbers. So simply after close everything in double quotes and followed by dot r, it will come.
Karnakar,
Yeah.
do we need to have a find first?
Yes, we need to use find
With,
first. After defining the pattern, we use find first. First, we define the
okay.
pattern first. Okay. Next, we define the pattern for port. Port underscore pattern. What's the pattern for port? It is made up of 5 digits actually. It is made up of 5 digits. Okay. Simply we can write 5 digits. So we can use here 0 to 9. It is made up of. So can we have less than 5 digits in the IP address or port number?
4 or 5.
4 or 5, even we can have less number also, but mostly 4 or 5 will be there. So even it can have 2 digits also. Port number can be like that also, but generally we go with 4 and 5. Let us go with some minimum 1 to 5, maximum 5. But if you try to see here, even we have something, here, if you try to find apply find first, and we are going to there's a chance that we may get this 129, the first number. So but we have to skip it. We have to exactly point to this. We should be able to extract exactly this value, the port only, not any one of these values. So further what you do is, the unification, the identification must be unique. For that, use hyphen space. Why am I using hyphen space here? It is, this is this one. Every number is it is having an hyphen and space before it, in every record. So I use that for unique identification of that particular number. Okay, later I will remove, later we shall remove this space and hyphen, but first to identify uniquely, let us go with it. If we do not use this, there is a chance that it may identify this 129, 19 are the port numbers. But because they come, even they follow they match the pattern. So to avoid that, we can use this one, and dot r. That's it. Now remember here, in this pattern, after extracting that port, we need to remove hyphen and space. Remember that. Okay. And finally, define the pattern for time underscore pattern equal to, define the pattern for time. Can you tell me what is the pattern for time now? It is made up of 15 September, year is some 2013, something like that. How do we define the pattern for it? So if 15, so the number can be any value, right? 0 to, not 0, 1 to 31. The date can be between 1 to 31. So let's go with 0 to 9, and the number can be one digit or two digits. Okay, separated by slash. They're separated by slash, and followed by SEP. That is, the month is made up of 3 characters here. Month is represented as 3 characters. The first character is capital letter, and remaining 2 characters are small letters. So we have to be particular about this. So the first letter is capital letter, followed by small letters. How many small letters? We have 2. So if it is January, it would be JAN. It is September is SEP. So we're assuming that it is made up of 2 characters. So one capital letter character and 2 small letter characters, lowercase letters. Okay, and this is followed by again slash, followed by 4 digits, 0 to 9, 4 digits, followed by colon, and again 0 to 9 made up of 2 digits. Okay, and again colon, and again 0 to 9 made up of 2 digits. Again I think one more colon is there. So 0 to 9, 2. It is made up of
Karnakar initial dates, right? If we give 0 to 9, will it not take 92, which is also a 2-digit number, and it is not valid date?
92. Where is 92?
No, no, no. See, 15 is a number, right?
Yes,
In
yes,
the date time
yes, yes.
format. So initially, we are giving 0 to 9 and 2
Yes,
digits should
yes, yes,
maximum
yes.
2 digits. So if 92 is also a 2-digit number, but it is not a valid date number,
But
right?
Yeah,
we don't.
Will it not
Karnakar,
take 92?
the question is like, let's say instead of 15, it might be 37 or 38. So we should accept 1 to 31 values.
Yes, yes.
So
So should we not take
whichever,
each digit individually?
yeah,
0
in
to
whichever,
3, 1 comma 1, and 0 to 9.
Yes, yes.
yeah, one more
We have
question.
defined the range of values. We have defined the range of
Yeah.
values. Okay, we can do
Karnataka,
both.
one more thing.
Yeah.
After 31, we should consider it as a bad record. So it should not be considered as like
Yes, yes.
exact record. We need to exclude
That's
that
what
as well.
it, when we use this pattern to identify only those only. Okay. Otherwise, after picking this, we can make a check. We can make a check after this. Let me first finish this one. Later we can eliminate. If it is the date, if the date is above what you call as 31, it is above 31 or below 1, we have to eliminate all those records. Those records are bad records, right? We have to eliminate, we have to avoid them. So we shall do that in the coming up transformation. We shall eliminate them. That's not an issue. Okay. And is this fine? Just understand this one, and we will do that again. So it is 0 to 9 2 followed by what here up to here we got the data now. We have defined the pattern from here to here now. Followed by space. Followed by say simply give space here and to specify place be careful here. Use that in this straight brackets. Do not use directly. Do not use it directly. Use it in scale the straight brackets. Why? Because this place is used as one of the regular expression. It's used in regular expression framing. So do not use it directly. It will throw an error. So and followed by 0 to 9 4 digits. So whatever you have said just now, we will do the requirement. Okay, we'll fulfill that. Don't worry about that. First, I'm going with this. Okay, three patterns are defined here. Now we shall try to extract these three, information, these three fields from every record. So, well, RDD4 equal to RDD3. We are extracting from RDD3 dot map of x implies. We can use, if you're trying to do multiple operations, use this curly brace, map of curly brace, and you can write multiple statements in this. If you're going with only one statement, then need not to use for curly brace. You can use normal parenthesis and you can use this operation. Okay. Well, next first we need to extract IP address. Well, IP equal to, so this is the pattern we have defined for extracting IP address. So IP underscore pattern, IP underscore pattern, sorry, IP underscore pattern dot find first in x. Next one, well, port uh, equal to port port underscore pattern dot find first in of x dot get. So this port under this is going to, this statement is going to get a hyphen space as well along with this 698.27. Okay, this as along with this is going to get hyphen and space. Now after getting this we need to remove it. We need to remove that hyphen and space. That is, the first two characters must be sliced. Now we can use here slice operation. Okay, so how do we slice it? Simply I use it in a second step. Val port 1 equal to port dot slice. Slice of where from? So the index of a string always starts with 0. So the index of hyphen would be 0, the index of space would be 1, and the index of the starting this digit would be equal to 2. So I need from 2 until where? Till the end of the string. Till the end of the string. So I use a port dot length till the end of the string. So up to the length, the entire string. Okay, this is what going to. Let me use port 1.
it,
Otherwise, port 1 here.
yeah.
Yeah, port 1. Sorry. Now after this, we need to extract the timestamp here. So val time equal to, so time underscore pattern dot find first in x dot get. That's fine. So now we got IP, port 1 and time. Let us form a tuple out of this. For every record we are forming, fetching 3 records. Okay, IP, port, sorry, port 1 and time, and close this. Okay, this is what we got here: string, string, and string. But actually what is the IP address is string. That is okay. Why? Because we have a dot in between the fields, in between the numbers. Then what about port number? It must be an integer, right? It must be an integer. So somewhere we have to make some change here. We need to convert into integer. Let me do this once again. IP, next port 1. So here after converting, doing this, we can convert into int, dot to int, and time and framing of a tuple from every record and closing it. Now get string, int, and string. Let me print this first. Some sample records of this RDD4. RDD4 of some take of 20 dot for each of println. For each of println, I'm printing every record in a separate line. Can you see this now? The first one is IP, second is port, and third is the timestamp. Is it fine?
Yeah, it is good, but just want to know how did it, how is it able to identify the date correctly?
Date.
Yeah.
Yeah. I will come to it now. I will come to it. Don't worry now. So now we need to understand that the very first one, that is in the date, as you have said, so it should accept only two digits, right? It should accept only two digits. That is not, sorry, 1 to 31, not more than 31. It should eliminate. It should avoid the dates which are having above 31 and below 1. Those dates we have to, those records we have to avoid them. So how shall we avoid them? So how shall we, from this, I want to focus on the now RDD4. So RDD4 is made up of, so every record in this RDD4 is made up of how many fields? Three fields: string, int, and string. So what would be our third? What would be our the timestamp in which field? Second field or third field or first field? It is going to be the third field, right? So how do we say that? So in the third field, the first two in the third field before this slash, okay, before this slash, okay, the third field before this slash, the number has to be one. Minimum, it can be 1 and maximum 31, not more than that. So if something it is not or 31, it is not 1 or 31, we have to make it as what? We have to neglect those records. That's what we have to try, we have to do now, right? So let us do that. RDD5 equal to, sorry, 5 equal to RDD4 dot filter. So we have to filter, right? Out of all the records, if there are any bad records which do not follow our condition. What is the condition is? The date, whatever the data we have there, the date should not exceed the value 31. That's what we are looking for, right? So X implies, so X dot underscore 3, third field. We are applying the condition on the third field. X dot underscore 3 dot slice. So how many you know how much data you are expecting from it actually? Sorry, so what is that you are expecting to be? Whether the date you are expecting to be only 2 digits, or it can be 3 digits also, 3 digits or 4 digits, expecting something like that.
No, only two
Only
digits.
2 digits. So the 2 digits must be minimum 1 and maximum is 2. Okay, so in that case we can go like this, that is x dot slice, sorry, not x dot, x dot underscore 3 third field dot slice. So where do you want to slice? The first two fields, the first two characters I would like to slice, that is from 0 to 2. So if it gives 0 to 2, it will take up to 1, 0 and 1, 0 and 1. Okay, dot to int. So we are, but basically it is a string, so we are converting. So from this entire string, we are selecting only the first two fields, first two characters, that is with this x dot underscore 3 dot slice of 2, and we are converting into integer. And the condition is x dot underscore 3 should be uh, less than or equal to 31. That should be less than or equal to, or we can say that less than or equal to 31. And otherwise I will write like this, just like this, while date equal to x dot underscore 3 uh, dot slice of 0 comma 2 dot to int. So we get the data into it. Now condition is date must be greater than 1 and date must be less than or equal to 31. Okay, date must be greater than 1 and the date must be less than or equal to 31. Is it fine? This is what we are doing, right? So we are extracting first two characters from it, we are converting into integer, and we are specifying this condition here: date must be greater than 1, sorry, not greater than 1, greater than or equal to 1, right? Greater than or equal to 1, greater than or equal to 1, and less than or equal to 31. Fine.
Yes.
This is how we can filter the data like this. Now we can apply the logic, again we get the data. right? RDD5. I think we don't have anything like that. Let us but if we have anything something like that, it will filter it. It filter, not a problem. So let us make a count. Before doing filter operation, what is the count of records? You get the count of records. After applying the upper count filter operation, if there is any change, if there is some bad records, it will delete neglect all those bad records. But we don't have any bad records, something like that. So we got the same number of records. This is how we can filter the data even after doing that. Fine. Okay. Now this is fine. Now we got the data into RDD5. So
Yeah, Karnakar,
yeah,
can we please do identify dot takeoff file kind of thing?
yeah, I am doing that.
Want to know.
Take off. Let me send 20 dot for each of parental element. It would be same. It's not a thing. It would be same. Okay. Now we shall convert this into a data frame because we can do analysis on the data only after converting into a data frame. Then only the data frame can be written into Hive. Our target is to write this entire data as a table into Hive, isn't it? The three fields. So three columns are there here. 1, 2, 3. Three columns. So what the type of the RDD5? You can see here. The first type is string, second type is integer, and third type is string again. So again, we need to find out a way to find out, convert it into a actually timestamp. The third field data has to be timestamp actually, isn't it? It has to be timestamp. So we can use string and we can use int. That's okay, fine for the first two fields, but for the third one, it has to be timestamp. We can convert that string into timestamp. We can change the data type in data frame operations. We can do that, and after converting it, we can load it into Hive as a table. Fine. Now the second step is, now we need to convert this RDD. We have to create a data frame, not conversion. Create a data frame out of this RDD. So what do we do is val df1 equal to rdd5 dot to df. So with the column names, I give the column name. The first column name is IP address. Second column is port number. And third column is, I say, timestamp. Okay, let me show you this one. Now this statement will convert, dot to df will convert will not convert, will create a data frame out of RDD. RDD5 is RDD here, and dot to df is a function which will create a data frame out of it. Okay, remember this. So till now we have performed RD operations, filter operation, map operation, and now we are creating a data frame out of it, the RDD. Okay, this is the internal conversion. Already we know what is data frame is. So now this data has to be converted into structured format. Why? Because data frame is a structured form. So let us try to print this now. df1 dot show on data frame. If you want to see the records of data frame, we use the function called as show operation here. Just see this one, df1 dot show. Can you see this now? IP address, port number, and timestamp. These are three features we got as a data frame. Got it?
Yes, Karnakar.
Okay. And here, uh, do you require, now we shall try to perform some operations on this data frame. Why? Because see here now, IP address. If you see the IP address, there's a chance of repetition of IP addresses. Why? Because the same user are from same system. The user may generate some different logs. Different logs can be generated. You observe here, 209, the IP address is same, and even here also the IP address is same. Here also the IP address is same. So I want to get unique IP addresses. I want to get the data to be arranged based on unique IP address. How do we do it? Because the data has to be grouped. Something like that. The data has to be grouped based on the IP address. So how many events are generated? How many logs are generated from each IP address? So for that, what has to be done? First, we need to group the data based on IP address. Later, we can find out the number of events or logs generated for every IP address. We can do that. You got my point right here. The requirement is something like this. The requirement is we need to group the data. The requirement is something like this. In general statement, we need to find out the number of events or number of logs generated from every IP address. So how do we do it? That we do it first by grouping the data based on the IP address here and making a count on the remaining records. So let me show you that. Val df2 equal to df1 dot select all the records. This is how we use select all the records. Remember this one. So here itself you need to understand, what is the syntax, what we are trying to do here. You have to select all the records and group the data first. Group by what? Which field we are using for grouping operation here? IP address we are using for grouping. We are trying to group the data based on IP address, followed by, after grouping the data of IP address, what is our task here? Actually, we need to count the number of logs generated for each IP address. Okay, so here we use the operation called as aggregation of count of, we can use count of star here. This let me show you this one. Let me run. It works or not. Yeah, I think this is going to work. Now let's see this. df2 dot show. So grouping operation will take time. So it is processing, internet is processing the data, grouping the data based on IP address.
So, Karnakar,
Yeah, yeah.
whenever we do any operation on any data frame or RDD, we have to create another a reference, right? Or we can override using var on df1 itself.
Yes, that's what we are doing val, right? Every time we are using val.
Yeah, we can also use var and override on it, right?
Yes, but no, we don't override. I am telling you again, you are getting confused here. The data will not be overwritten. RDD data frames, all these are immutable objects. They cannot be overwritten, but they become when we
Oh,
use
even
val.
data frame also. Okay.
Yes, everywhere.
Okay.
The entire Spark, every object is immutable object only. Remember. Okay.
Oh, okay. 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 Got it.
Okay. Now
Yes.
see this IP address correspond to the first IP address. How many records are there? Two records. There is two logs are generated. So you have correspondingly, for all that for this we have four records. For this, from this IP address, four logs are generated. From this IP address, likewise we have the IP address is corresponding number of events or logs generated. Fine. So just to go through the syntax of this one. If there is any doubt in this or any confusion in this, please let me know in this statement.
Karnakar,
Yeah.
one more way is like
Mm.
before going to data frames,
Mm.
can we store the final RDD into a file and start reading it? I mean, say like from HDFS or local file system and start reading it on Hive tables also, it's fine, right?
Sure. That can be done. That can be done.
Yeah. So now we are dealing with data frames. The final
Yes.
output have to be stored in Hive again, right?
Yes. So if you
Okay.
want that RDD at any point, RDD5 is the final RDD, right? Created. We can store that
Hmm.
RDD5. That's not a problem. We can store it, and from
Yeah.
there we can read the data again. That we can do.
Yeah. Yeah. We shall close with. I mean, instead of saying close, shall we complete with the data frame now? And as I already know how to read the data from HDFS or local file system, because we need to go with the Spark SQL context right over there.
Yes, when I'm telling you, here we have created data frame out of RD. For that we have used a function called as dot to df, isn't it? This
Yes.
is what
Yes.
we have used.
Yes.
If we're
Yes.
directly creating, if we're directly trying to create data frame out of a file, I'm telling you out of a file, there we use
Mhm.
SQL context dot read dot format. That's all we have discussed in the previous session. SQL context read dot format. What is the type of file format that we read? Okay,
Okay.
remember this point. If it is from RDD, we use .2df. If it is directly from a file, we use SQL context dot read dot format. Okay, you have to
And
do.
Karnakar,
Yeah, please.
one more question. Don't think it's real. So
Okay.
these data frames will allocate a memory, right?
Yes. Yes, memory will be created for the objects, right? All these objects. Yes, any memory will be created for all these objects. That's it. I didn't get your question properly. Ganesh, please. Yes, Hima and Hina, I know you are not at all responding. Are you okay with this? Any doubts or anything to know about this still? Please let me know.
Karnakar,
Yeah.
what my question is,
Yeah.
so this will be stored in some other location, but we don't know the location, right? Here,
We don't need
should
location because
should
we'll continue it. Everything we are doing internally in Spark itself. We are not loading. Finally, after
yeah.
we are getting the required output, we are directly loading into Hive.
Okay, from data frames also we can store it to the Hive.
Yes, exactly. That's what we are trying to do now. The next step is that only.
Okay, okay.
Okay. Right. Is it fine, Hina, Hima, from your side? Please, I would like to know. Is it clear or not?
I have some doubts. I think
Yeah.
I'll get back to you, Karnakar. It
Oh,
might
okay.
disturb the session.
Yeah, fine. But at this point, we are not. No, we did not save in Hive. We did not save in Hive. We came up to DF2, and this is the data we have in DF2. Now we have to save this DF2 into Hive. That's what I'm trying. Otherwise, we can save DF1, whatever we want. Let us save both DF1 as well as DF2 into the Hive. Can you see something here? So every time when we are doing this operation df2.show, it is taking some time to process the data, isn't it? It is taking some time to process the data. Are you able to understand this one? Even I do again, if I do this operation again, see this. Again, it will take some time to process the data.
We can do persist, right?
Yes, exactly. Okay, that will come to it. Yes. So which data we can persist here? We can persist after grouping operation is a costly operation. So persist the data of that group result. Thus df2 itself is a result of grouping operation. Persist it. So how do we persist it? df2 dot persist. df2 dot persist. Okay. And if you see this now, very first time it will take some time, but Spark is memory computation. Why take? Yes, that's what I'm telling. Even though it is memory computation, it will take some time, right? What it may be. If you do it directly on the disk, if you try to do it on the disk, it will take more time compared to it. So just observe now, we have persisted this data frame. We have persisted this data frame, and we have performed the first time operation. So it has taken some say, few seconds here. But if you apply same logic again, apply same operation, it won't take that much time now. It will show the result immediately. You throw this immediately. It won't take that time. Why? Because we have persisted it. I will come to that what persistence is after this one. I will. So how we can make some data to be accessed faster is by persisting it. Remember this point here now. So as part of your question, it will be added to it can be an answer to your question. That is, if you want to access some data faster in memory, persist it. I will come to it what persistence is, but remember that here we have to persist it. Okay. Now this is fine. Here we have the data in df2. Now we can save the data in df2 or df1 also, both. I can save them to. Let me first go with df1. I save both this data as well as that data to Hive. So write dot save as table of the database name in Hive, and let me call it as web table 1. This is very simple. df1 dot write dot save as table of default is the database name, and web table 1 will be the table name. Okay. We can minimize the time, we can reduce the time. Even if you persist df1 also, it won't take this much time. It will be done in immediate. It will be done immediately. That we shall discuss about that maybe in the next session about the persistence. What is persistence? How does it work? We shall discuss about it. Now that is done. So let us try to write second data frame also. This won't take time. This won't take time. Why? Because it is already persisted. So let me call this table 2. So web table 1, web table 2. I think something wrong. What is that? Web table 2 contains invalid characters. So please use alias name to rename it. Okay. So let me use some alias name to it. Age of count as. This is specifying the alias name. This is specifying the alias name for it. Okay, remember this. And df2 dot y dot table of table 2. So web table 1, web table 2. These must be created as tables under default database in Hive. Okay, under default database in Hive. So after finishing this, we shall open Hive and we shall try to see whether data is loaded into Hive or not. I think it is done. Yes, it is done. Now let us open. Let us go with another one here, and let us open Hive. How do we open Hive prompt? How to open Hive prompt? Simply Hive. I think you know about this. This Hive. So let us verify whether data is written into Hive or not. We have to verify it, right? Just by giving the command is not going to work. We have to verify whether it is working or not. Let us do that. Yes, destroying Hive prompt. Show databases. First, we should see what databases we have in it. So, what is the database we have used there? For storing it, default. Database name is default. So, use default and show tables in it. So, what are the tables that we have saved just now? Web table 1 and web table 2. We should have those two tables here. Are you able to see these two tables now? Web table 1 and web table 2. So try to print some data of this web table 1. How do you perform? Get the record from this table. Select start from web table 1. Limit some, let us say some 10. Just type in only 10 rows. You got data right? First 10 fields, first 10 rows here. Okay. And similarly from second table, web table 2. Got it? Fine. Any doubts or any questions in this, please?
Karnakar, are there any limitations like on memory or like data frames?
Limitations. Yes, and no, not limitations. No, we can't say limitations actually, but improvised. The improvised objects compared to data frames are data sets. The improvised version, the improvised data objects. We don't call
Okay.
it as a limitation, improvised.
Okay. And Karnakar, let's say like how long these data frames can store the results, or is it's a kind of temporary storage, or like
No,
it's kind of.
Hive is permanent storage, right?
No,
Hive
no,
is
I'm
permanent.
asking on data frame. I'm
No,
asking on
no,
data frame.
yes. When we come to RDD or data frame, this is only processing, right? Spark is for processing. Once we
Yes.
close the application, we lose RDD data for everything. We lose everything, right? Everything is
Yes.
maintained memory only. We lose everything. It is not permanent storage. That is the reason we process them, but we process the data by using these objects, and we finally load the result into somewhere, like in
Yes.
some storage
Okay.
system. That's what we are doing here, isn't it?
So here we have gone with Hive storage, like HDFS storage with the Hive tables, right?
Yes.
So we can do it on the same with HBase
Yes,
as well,
exactly. We can do that
right?
also. Yes, in the coming up
Okay.
sessions, we are going to deal every day, in every use case, we are going to see different storage systems. Today I have seen
Okay.
HDFS to Hive. Tomorrow we shall see RDBMS, something like that. Different file systems, different types of files, different types of storage systems. We are going to see in all the coming up sessions. Okay, is it fine now?
Yes, Karnakar.
And before this, we can do one more thing also. That is, today we have implemented this. We have loaded the data into this Hive table. Tomorrow again. Let us say in the real time. So we do this operation. Let us assume we are doing this operation, this processing every day. Let us assume we are doing this every day. So if you are doing this, what should happen to the data that is coming tomorrow? Whether it has to be written to the same table or different tables?
It has to be written to the same table, but it should
Yes,
append.
append, right? So we can choose when we are writing the data into this Hive table, we can choose in which mode the data has to be written to the Hive tables. We can choose that mode. So use here mode append, small letter, sorry. So we can choose append. So if we choose append, every time what are the new data, if it run what you call as continuously multiple times, then every time the data gets appended. If we want to overwrite it, we can just simply use this append with overwrite. We can replace that append keyword with overwrite. Got it? So by default, it says that the file is already existing, table is already existing. Otherwise, it will go with the overwriting. If you want to make it append, go with append, mode of append. That's it. The data will be overwritten.
So
Not
like
over,
if
sorry,
we
appended.
don't give the mode as append every time it truncate and load the table.
Yes, today, just now we have performed, previously we have performed that operation, right? We have loaded some data into that table. If we are doing this
Yeah.
operation again, so whatever the data we have in DF2, again that will append it to already existing records.
Existing. If we would have not given the right dot mode append and instead we have write dot save table,
Hmm.
it would have deleted the old data and rewrite the table
Yes,
with new
yes,
data,
yes,
right?
that's going to happen.
Uh,
So in order
Yeah.
not to allow,
Karnakar,
not to
One
allow
more.
that, yeah.
Karnataka, one more thing. So
Hmm.
in the real time, these log files will be generated with dates, right?
Yes, dates only.
So we have to with a date level, everyday date level, right?
Yes,
Then we need to push it into the RDD. So everyday date
yes,
and pushing it to the RDD, and from there it is like we are appending the data into this default database with web table, right?
yes, exactly. So we need to partition the table. We need to load the data into Hive as partitions. Every partition will be have data. No, not date. Sorry, date. Based on the date, we need to partition data in Hive. That's what you're asking, right?
And
Yes.
yeah. One more thing. Does this Spark will support the bucketing as well?
Yes.
No, right?
Yes. Bucketing is not supported for totally. I think this Spark 1.6 version does not support for total functionality, but maybe in the future, the latest versions 2.2, 2.3, it is supporting that. It's supporting
Okay.
bucketing also, but not totally. They said that bucketing is not supported by the Hive Spark totally, but remaining operations like partitions and indexing, everything is supported by this data frames. That is Spark 3.
So we can just write it into the partition table. From there, like we
Yes,
can
we can do from here itself.
from
We can do
no,
from
no, no. From partition, no. We are dealing with partition table, right? If it is not supporting with the bucketing,
Hmm.
from partition table we can load it into the bucketed table, right?
Yes, we can load. We can load that.
Okay.
We can load from
Okay.
Hive to Hive. We can load that. That we can do from directly from Hive shell. Okay. Yeah. Any questions from your side, Hina? Okay. So there's still. I will go through recording. Okay, fine. Now see this actually df1. Where's df1? Df1 dot show or df1 dot show. So here actually the timestamp. This is the data type is string. String. How do we know the schema of this one is? Simply we can type a df1 dot print schema. Sorry, say small letter here. print schema. This is going to give the data type. But actually, the data type of this timestamp has to be timestamp only, not string. It has to be timestamp. We need to change the data type of this one. We need to change the data type of this, and we need to convert that string into a timestamp, so that we can run the queries directly. That fetching the hours, fetching the date, fetching the month, fetching the year. Those operations we need to perform actually. So
Hello, Karnakar, we lost your voice.